Hello everyone. I just wanted to go over some of the most frequently missed problems from the 5.5 Practice A. This is from the Unit 3 Lesson 4 set of notes. So I'm going to go over the circled problems with you. For the first little grouping, it says solve the equation. So here's the deal. Usually when we have an exponential, if this has a base of 2, I want to try to make the other side also have a base of 2. But sometimes there's no way that we can actually get that specific base. And when that happens, we have to take a different approach. So there's no way I'm going to change this 5 into a base of 2. So what you do instead is whatever this base is, to both sides, you're going to do a log of whatever that number is as your base. So log base 2 of 2 to the power of x. And if you take a log base 2 to the left side, you also have to do a log base 2 on the right side. So note that I took a log base 2 to both sides. That means it's still an equivalent statement. And when I do that, then you have to think of our other properties, how when these bases match, they undo each other, and then that would drop down. So now x is equal to log base 2 of 5. And at this point, I'm going to type it into my calculator. Log base 2 of 5, when you type it into your calculator, it's always log of the big number divided by a log of the base smaller number. So in my calculator, that's actually really small. Here, let me write it over here. In my calculator, when I want to type this in, it would be log 5 divided by log 2. And you would type that in, and you get about 2.32 for your answer. 5, very similar kind of scenario. I have a base of 8 and I have a 35. I could write 8 as 2 cubed, but there's no way that I can write 35 with either an 8 or a 2. So since that is a base of 8 on both sides, I'm going to do log base 8 of the 8 to the power of x. Again, the whole thing's to get those to match so the x can drop down. But if you did a log base 8 on the left, you have to do a log base 8 on the right. And as you can see, I really don't have a lot of room to be writing these on the worksheet. You should definitely be probably writing these out on notebook paper so you have more room to get all these done. So now that these match, I can go ahead and say that, okay, they undo each other, the x drops down. So I have log base 8 of 35. That would be the exact answer. But then I can type that into my calculator. You're going to do log of the big number. So log 35 divided by log of the small little number. So the base goes on the bottom. And when you type that into your calculator, you should get somewhere around, let's see, 1.71. Now 6 is a different story because I actually can rewrite these with the same basis. I see 16, and I know this is a fraction, but I still see a 4, and I know I can easily rewrite 16 with a base of 4. So I'm going to kind of come over here just so I have more room. 16 is 4 squared. 4 squared, 16, and then next to that little squared, you're going to have the 3x minus 2 in parentheses because you're going to have to distribute that 2 to both the 3x and that negative 2. 1/4 I can rewrite as 4 to the negative first power. 4 to the negative first is 1/4, and then I have that 5 minus x. Again, bear with me, I'm squishing this. It's actually off the paper, but as long as you can still see it, that's all I care about. Now that the bases match, since they are already equivalent, I can ignore them, and then the other stuff just drops down. So really, I'm just looking at the powers because the bases already match. So I'm going to have 2 that I have to distribute to the 3x minus 2. And that's going to equal that negative 1 that I have to distribute to that 5 minus x. So it looks like I get 6x minus 4 is equal to negative 5 plus x. I'm going to kind of multitask here. I'm going to subtract the x over, and at the same time I'm going to add the 4. 6x minus x is 5x. Negative 5 plus 4 is negative 1, and then you divide, so you get negative 1/5. There you have it. Next, we're going to jump down to number 12, and they want me to solve this equation. Again, I would totally do this on notebook paper because I'm going to come up here and use all of this space, but you probably had to do some of these other problems. When I look at this, Don't forget, if there's no number written here, it has a base of 10. So really, I'm going to start with that base, and I would say 10 to the power of 3 is equal to that 10x minus 7. So you just rewrite it so that it's no longer a log. You're writing it in exponential form, and now I can solve. 10 cubed is 1,000, so that's going to equal the 10x minus 7. Add the 7 over, so you get 1,007 is equal to 10x. And then you would divide by 10. So you get 100.7 for your answer. 15 and 17, it says solve the equation and check for extraneous solutions. So I'm going to pull 15 up here. First things first, we need to condense this. Since this is log base 3 and this is log base 3, and I'm adding, I can condense it down to log base 3 of the 3x times the 2x plus 1 and set that equal to 2. And then once I have that step, I can change this log to an exponential. So I have a base of 3, and it would be squared is equal to this 3x that I have to distribute to that 2x plus 1. 3 squared is 9. 3x times 2x, that's going to be 6x squared. 3x times 1 is 3x. And since I have an x squared and an x, I want everything on one side, and I want my x squared to stay positive, which means I'm going to subtract the 9 over. So I would get 0 is equal to 6x squared plus 3x minus 9. And I am going to have to factor this, but before I factor it, I see that they all have a 3 in common. So I am going to divide out that 3. So this is going to be 0 is equal to, here's the 3 that I divided out, it goes in front, and then I get 2x squared plus x minus 3. You should be good at factoring by now. I don't know what method you use, but I like to say, since this has a number in front, I'm going to do the cheater step. So 2x squared, usually if this was just an x squared, say if that was an x squared, we do x and x. Since it has a number in front of the x squared, I do this extra step above the parentheses. I call it a cheater step. So whatever this is what I'm going to write. So since it's a 2x squared, I'm going to do a baby 2x and a baby 2x. Knowing that 2 times 2 is 4, so right now I have extra numbers, but that's why it's the cheater step. You do a little rainbow, you multiply the ends of your rainbow. 2 times negative 3, I'm multiplying for negative 6, and I'm adding for this middle guy, which if there's nothing there, it's just a 1. So 2 magic numbers that multiply for negative 6 and add for 1. For some people, this is the hardest part. Hopefully you're thinking 3 and negative 2. Because when you multiply, you get a negative 6, but when you add, you get a positive 1. So 3 would be plus 3, and then the minus 2. Now here's the deal with that pink cheater step. If these numbers have something in common, you divide it out, and that number just disappears. So here, 2 and 3 have nothing in common. That would just drop down. But here I could take a 2 out. If I take a 2 out, I get an x minus 1. And just so you can see, if I do a quick check, 2x times x gives me my 2x squared. 3 times negative 1 is a negative 3. Now it doesn't check the middle term. You could fully distribute if you want to check the middle term. But usually a quick check is sufficient. So the idea if 0 is equal to 3 times a number, clearly 3 is irrelevant because 0 doesn't equal 3. That's not true. But the 2x plus 3, we would set equal to 0 and solve. That could be a 0. Or the x minus 1, we set equal to 0 and solve. So I'm going to subtract the 3 over, divide by 2. I get negative 3 halves as a potential answer. Add the 1 over, I get x equals 1 as a potential answer. Because don't forget, they very specifically told me to check for extraneous. See that word extra? Extra solutions. A solution that I get that when I plug it in, it doesn't work. So for this one, anything, if we have an x after a log, this value always has to be positive. So I can see right now, if I take negative 3 halves times 3, a negative times a positive is going to be a negative. So that one's out. So if you plug in a number and it comes after a log and it makes the log, like whatever this part is after the log a negative, you can't count that answer. So that one's out. So x equals 1 is our only answer. 17, I'm going to go, again, this is why I said do it on notebook paper, just run out of room. I'm going to go right underneath 15. And I see log base 6 plus a log base 6. So since they're both log base 6s, I'm going to condense it down to 1 log base 6. and addition would change to multiplication. So it's going to be 2x squared times the 3 is equal to 2. I'd get log base 6 of, when I multiply these together, I get a 6x squared is equal to 2. And then I could rewrite this starting with the base. So 6 squared is equal to 6x squared. 6 squared is 36. Now, here is a big silly mistake area. I will have people that will, when they see this, they'll do the square root of both sides. You cannot do the square root here yet until this x is by itself. So you need to divide by 6 first and foremost. People make this mistake all the time. So I have x squared is equal to 36 divided by 6 is 6. Now, when you have an x squared, you take the square root of both sides. Usually it's a plus and a minus. However, if I look at this original problem, don't forget, if I plug in a value, I can't have any negatives. Well, if you check it out, if I take the negative, since I'm squaring it anyways, it's always going to become a positive. So actually, I can keep both the positive and the negative root 6 for my final answer. So again, the negative is what I want to be careful of. If this would have just been a 2x, I would not have counted the negative root 6 because that would have gave me a negative after a log. But since I'm squaring it, the squared will take away the negative, and this is just a 3, so that's just going to stay a 3. So I can count both the plus and the minus root 6 for that answer. So those are the most frequently missed questions on the 5.5 Practice A homework, so hopefully that helped you out.